Hello and welcome to another edition of Farm Radio. Today what we have is this Panasonic, I believe this is the RE-7671. It says RE-7671. Oh, okay, it's listed here. This unit right here, I was troubleshooting a turntable the other day with a ceramic pickup, and I wanted to test it with a receiver that had a ceramic phono input, and I thought, well, I'll grab this older Panasonic. I never checked it out, but here's what we found. Okay, I'm going to clean these controls. Power up. At first I thought my speakers were blown, my test speakers from one of the previous videos. Yes, and now the woofers are hooked up, and the left channel is distorted. Do a little troubleshooting. Here's our amplifier section right here. And lo and behold, they gave us a nice printed schematic on the inside cover. I didn't realize how old this is. This Sam's is from 1968. So this is pretty early as far as Panasonic stereos. I mean, it looks older, but I didn't think it was that old. I thought it was maybe 70s, but so I'm sure we have some dried capacitors. I wanted to try the amplifier method where I pass the signal through, but I'm just going to signal trace it with my my amplifier here, and I'll find the bad section. I'll trace it and from the volume and find it that way. First off, I'm going to clean these controls, and the way I'm going to clean them is a way I learned in another video, and also someone chimed in on one of my videos and said you're using deoxide gold. That's for switches, not for pots. Well, I know I've never had a problem with it because it has no lubricant, they say, but this stuff has lubricant. And I don't have to go crazy spraying the thing. All I do is what I learned in another video is you just have to wet the phenolic in like a sponge. It'll soak it all up, and I've had good success with this. And yeah, if it's real bad, I may have to go in, because I've had trouble with spraying. This stuff doesn't seem to be soaking up like the other stuff, but anyway, I've had good luck with this method, and I've had trouble if I spray. There's a good chance I've frosted dial glasses before. The plastic I've damaged. The spray just is out of control. So I'm just going to wet these and get back to them. Okay, after a few minutes, those are all sucked up and wet. And I was able to reach the wiper on each one of them and work it a few times. And there's our left channel, as I was saying. Stocking the shelves, driving the trucks. It sounds like a bad transistor, but I don't believe it is. But we'll soon find that out. Okay, I can bring up the schematic on the big screen in a minute, but here's our selector switch. Where we choose our input. It starts with the phono over here, and AM, FM, etc. So it's fed right into this first stage right here. So I'm going to start with Q17. I don't know what they call it over here. There's your phono. It's drawn a little different, but basically right here and right here. Right here. And we're going to just follow it along and see which first AF amp, second AF amp, third AF amp, and the power amp. So let's see where it's going awry. The schematic inside is drawn really well. It's really tiny, but it's much better than the Sam's in the fact that it tells you things that the Sam's leaves out. Like here it says, I'm checking the signal, it says tape input right here. I'm like, well, that can't be the tape input because it doesn't have a tape input. It has speakers, phono, and record out. As I was testing for signal, I was saying I have good signal at the record out, and there isn't a record out on the Sam's, yet on the factory manual it does say phono, and then it says Oh, there it is. Record out, left, right. Right there. Another thing that it says it's nice, when you're stringing your dial, notes the tuning capacitor is positioned at maximum capacity. So that tells me down at 88 is the maximum, with the plates closed, is the maximum capacity. Oh, and there's other things over here about the picofarads, and it says 1P equals microfarad. And it tells you the transistor basing, and these transistors are so tiny in here. It's you can run into trouble trying to troubleshoot because they're so tiny and the leads are so close. So okay, I'm gonna carry on. Another thing I like is they really spell out the AM antenna 1, 2, 3, and 4, and it's labeled in here really well. That's always confused me. The antenna coil is labeled 1, 2, 3, and 4. Short sample right is clean. Left just sounds like garbage. I don't think it's any of the output transistors. They all seem good. I haven't checked voltages yet. I'm saying one of these capacitors is dried up. I'm going to try to probe around here from underneath and give a listen. It's hard. I have a pair of amplified headphones, and it's hard to hear the raspiness at such a low level, but it is there. I just got to try to see if I can locate where. We know it's good here at the tape jacks. That's these two transistors here. So we're losing it like right here. It's really hard to try to listen to these. One channel, suspect channel. Sounds okay at the output transistors, but it doesn't sound okay. It sounds about the same, but on the volume control, that one's definitely not as clear. And there isn't much going on there. I'll go back and check it, but signal's okay on the bass and the collector over here, bass collector. It sounds, maybe it's just not as good sounding. I'm going to check the bass of the driver here, if I can get to it. I brought it up on the big screen, so I'm going to check Q14. The driver, the bass. I'll check voltages 7.2, 0.8, 7.4. Again, I think it's something like that 200 microfarad electrolytic right there. Okay, here's where I stand. I've taken some measurements and I've listened through my amplified headset, and it's difficult with the impedance mismatching, I don't know, to hear the bad section. What I can tell you is, after hooking up regular pair of known good speakers, that it is the left channel, which is down here. But as I probe through, it just gets lousier and lousier and lousier. It's good at the tape out jacks. I'll just show you that real quick. It's good at the tape out jacks, which is right before the volume control. The problem begins right after the volume control. So here's my tape out here. Oh, come on. Both channels are fine. So that's the left tape output. But as I follow it through in this convoluted mess that they have here that isn't in the diagram, and I blew this up so I could follow it. So I'm going to put, oh, I think I'm on the collector of one of the outputs there. The bad channel. Come on. Sounds, that one sounds clear. That's the right channel. That's right here. which is what I thought was the collector. Anyway, the collector of the left channel is here. And be careful with this because it's a transformer output. The collector of the other channel I don't think I can do. Yeah, you gotta do this collector over here. This channel is just clear. This channel is just crappy. The whole channel, not in any particular point. It's good at the tape out jack, which is at the beginning, and I'm just beginning to think that it's just capacitors because it gets crappier and crappier and crappier as you go. It's not good. It's good. I'm using the SAMs here, you know, for Q18, but I'll just say Q13, Q14. It's good on the bass here. It's okay on the bass here, and then it starts falling apart. I'm gonna go with the I'm gonna go with these capacitors here. This 3.3 at 16, or this 10 at 6 here. Just feeding the bass because it's just crappy. I may take again some voltage measurements just to shore it up, but I'm telling you, it's working, but it's just crappy at the output, and it seems to manifest itself as it goes through. I usually would like to jump across with a capacitor. I was about to do that, but I'm afraid this is so tiny in here. It's crazy. I may do that a little bit, but we'll see. Okay, just a quick speaker test. That's the bad channel. That's the right. Okay, we're going to wrap this up here until I can think about this some more. I made a slight mistake on my dummy loads. I put some 50 ohm resistors in there. I had 10 ohms in there, and this is a 16 ohm set. So they were getting a little warm. Anyway, back to the collector of Q, we'll call it Sam's Q14. And it's crappy. Versus the collector of the good channel. Bad channel. Good channel. So that's the collector of Q14. We'll do the bass of Q14. Let's do the bass here and see what the bass sounds like. Oh, I thought that was the bass. I thought that is the bass. You gotta put the volume up to hear it though. The volume up a little. Let's go to the bass. Crappy. So let's go to the collector of 13, which is up here under this resistor. Crappy. Let's go to the other channel bass, which is pretty easy. I think it's right here. I don't think it's as crappy. Yeah, the bass. The first, yep. I'm going to increase the volume there a little bit on that channel. It's lower but clearer. And then I'll go back to the bass of Q13 on the bad channel, which is right here. That sounds good. Let's do that again. We're going to go from the collector of Q13. The collector of Q13. The collector of Q13, which is right here.
Can't get enough Nora Jones.
Crappy.
We'll take it back to the music with Judah and Orion.
Let's go to the base.
Showcase at 10. Stick around.
The base of Q13. I can't tell. I gotta turn the volume up a little more. Oh, my lead keeps bending. The base of Q13. And go to the base over here, which I think is here. Let's go to the collector again. Crappy. Bass. That's clear.
Fancy clothes and a wife with a big old diamond.
I'm gonna say Q13. Q13. I'm gonna leave it here while I think about that. Q13 right here, and Q13 is this guy right here. Q13 is on the Sams is this guy right here. Pretty simple. It's good here again at the record outs. So that means it's good here, obviously. After the volume control, it's crappy. It's good going in here. Crappy, 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 crappy. I think it's this one. As I was looking up the transistor, that's a 2SB173. I smelled some heat, and my 50 ohms there are getting toasty. Real toasty. Anyway, so lower the volume on that. That's a GE2, that 2SB173. We have some GE2s. I'll find something. Alright, we'll leave it for now. I think I'll tack another one in there next stop. Okay, back on the Panasonic. I'm going to establish a baseline before I do any work here. I have my speakers attached. I'll flip the power on here. Okay, right channel, left channel still crispy, staticky. So that's where we're going to start. I've managed to find in some stash here a couple of transistors. This one here, I do have a GE2, but I went through the stash nearby. This one's okay, but it's got the for Delco radio and old Cutlass. The milliamps are 200 milliamps, so it is a pretty good size. 200 milliamps, so that's a pretty good size. But I also found this one here, which is in the tester. Low power germanium transistor. It doesn't say it's across to the GE2, but what I found out, the pinning is the same. Someone wrote on it for Radio Shack tape recorder, and it tried in the car radio, but it overheated, so it's been opened. the current's 500 milliamps. Alright, I was a little concerned about the current draw because in the schematic here, they've noted the milliamps of each transistor. So if we're going to be doing the second AF amp, that's 0.6 milliamps. 0.6. Alright, the 2SB173. This one's 0.4, this one's 0.6. 0.6 milliamps, and this is good for 500 milliamps. So in the tester here, it gives us our, it does test good. Gain of 34. It says typically 100 or 120 on the packaging, and I did look up. This transistor has about that gain. Hold on. It says the gain is about 100. I think this is a suitable transistor. There's a data sheet for the 2SB173. And again, the pinout is the same, and it physically looks the same. So we're going to pop that bad boy in here. I just want to zoom in on this, and as you can see, the brown comes off the volume control here. Where is that brown? Right here. Right here, and goes in right there. This is the channel we want to change. This is the one right here we're going for. It's right after the volume control. This is before the volume control, and this is fine. This is where it goes haywire. So that's the one we're going after. Alright, to get this transistor out of here, I really hope it's this one, because it's nothing shy of a miracle to get this out without damage. You talk about miniaturization. You have it here. I'll show you. I have all three leads. Let me get some focus here. I have all three leads desoldered. You have that resistor there. You have a capacitor there. So that's the emitter on the left, the base in the middle, and the collector on the right. The collector on the right has the resistor. Looks like a 15K. See if we verify that. We're right here. Q13. Again, there are some discrepancies. There is no 15K across the on the collector. There's a 27K. That's the SAMs, and I refer to it as Q13 on the SAMs, but it's actually TR15 on the OEM diagram. And again, there's a 27K. Okay, just to recap, I have a 27K here. And I have I think that's alright, that's okay, so that's 12K here. I have a 12K and a 27K. It doesn't show that 15K on the diagram. Alright, the collector now will be on my right, on the left, which is, it's where that red writing is. It's not really a dot. And it corresponds with our new one, so it will be CBE, C base emitter. C base emitter. We'll pull him out. CBE. CBE, and I got a little shrink on the base. CBE. Now there's our new one, CBE 123. So I've gone ahead and taken a Sharpie and made my own little red dot on the collector, and I put the tubing on the base, and I scraped my leads. So here we go. We'll go CBE and stick this sucker in there. I pity the fool that was had to work on these in 1968 as a Panasonic warranty repair, authorized repair. This is This is not fun stuff. Alright, CBE. Okay, there he is, all installed. He sticks up a little more than the others. I just tacked him in here. I also went and replaced that 3.3 at 16. I did not have 3.3 out of everything. I had 2.2, 4.7, so there's a 4.7 at 25 in there. And now for the all-important smoke test. We'll apply power. Good news, we have 2 channels and no smoke. We have such crappy radio here, it's hard to find anything. Sports talk and blah blah blah. I still think the other channel sounds better. It's not as bad. It's not like it was, though. I can find a station here. Something I recognize. This is nothing. It's okay. I'm not 100% satisfied yet. I may do some recapping. The original transistor tests good and shows more gain. I'm going to say no, that was not the issue. The other channel's much clearer still.
NAMI, the nation's largest grassroots mental health organization.
Okay, on to some voltage checks.
Visit NAMI.org and learn more now. Find information, resources, get
working,
support,
but that
and
left
find
channel
out
is just
how you can best support others too. Again, that's
not right.
NAMI.org.
Okay, voltage measurements. That's the base, 4.1. It says 4.8. Collector. It's 3 volts, 2.9. It says 3.6. The emitter says 5 volts. The emitter is 4.2. Oh, let's try something else. Let's try C23 over here, which is this one right here. I don't think this capacitor tests that great.
Patients reportedly account for roughly 15%. Romania's more than 2,700 coronavirus cases so far.
I believe 6460 nanofarad is 6.4 microfarad. Turn my fume extractor off. So I found another 3.3, so I've gone back to the 3.3. ESR 57 ohms. That's kind of high, I think. And it reads out 6.1. So compare that to a new one here. Has much less lower ESR, and it reads 3.3, 1.5 ohm. And the loss is only 0.5%. Big difference, big difference. So these capacitors are junk. I don't think it's a transistor. I think it's just dried out capacitors. I changed the 470 here. Didn't make much difference. I'm going to keep going. This circuit is too simple to have much wrong with it. Well, I figured I'd start at the beginning, even though this shouldn't affect our issue here. But these guys are really good, and it pays to pay attention. So at the first transistor, I'm changing this 10 microfarad, and I'm making note of which way negative goes. And I'm like, negative goes to the 1200 ohm, 1.2K. And I'm looking, I'm like, no it doesn't, no it doesn't. But according to the schematic, the positive goes to the resistor. I go, that's not the way I took it out. Same over here. That's this resistor right here. Positive goes to the 1.2K. And I look at the capacitor. Look at the capacitor like anyone would. Negative. I know that's the way it came out. That's not negative. That's positive. Oh, let me get some, see if you can get that. That's not a negative symbol. That's a positive symbol. The black line denotes positive. Are you kidding me? That means I have to check this one and the other one we just changed. Sure enough, they're all that way. The black denotes positive. We have to flip this one around. And we have to take out that 3.3, which we have a replacement for, and make sure we do it opposite. Alright, now that we have all our capacitors installed with the proper polarity this time, we can give it another go. Hit the power.
In Brookline, I'm Santoro. Among the unprecedented 6.6 million charts last week.
That option because doing it digitally, she says, makes her uncomfortable. I feel controlled.
I'm going to keep going down the line here. I just want to notice the positive is facing this way and the opposite one is facing that way. Positive on the black stripe. Ugh. Okay, here's the update on the Panasonic. The problem still exists. I've been all over the place on this, but I'll recap what we've done. I've changed one transistor, which I thought was the culprit, but it didn't solve anything, so I have the original here, which I may reinstall. I went ahead and I recapped that channel just for the heck of it. There's nothing wrong with these caps other than high ESR, and maybe the value has drifted up a little bit, but the other channel is fine, so I don't suspect capacitors at all. But what I've gone ahead and done is I've ordered 2 output transistors. Reason being, all the bias voltages on these are fine. They're fantastic, actually. They're spot on. And when I trace the signal, I have some dummy loads on the outputs, and when I attach the signal tracer, well, the amplifier, to tack it on one of these outputs, the sound is clear. It's as if the unit can't power the speakers. It can't drive the speakers because it's clear. If I tack an amplifier on here, it's clear. But you can obviously see it's still working the same way it did, which means the left channel is crackly. Right is fine. I'm using the converter box audio.
Because there's still time to do something about it, and people understand that they can.
So when I hang a signal tracer off of here with the load, the sound is clear. It's as if these can't. I'm just going on a hunch, and I've ordered 2 new old stock output transistors. Again, the bias voltages are fine. Everything looks fine. Everything looks fine. Just the sound on that channel is bogus. I can't really isolate where it's going bad, and then again, if I trace it, it's clear with the dummy load attached. So we'll stop here. The other thing I need is a stereo eye. It's called 7.5 volt 75 milliamps. 7.5 volt 75 milliamp stereo indicator light. Other than that, we'll get back on this later, so we're going to shelf this for the moment. Stand by when we replace the original output transistors. Okay, back on the Panasonic here. I was going to try some output transistors from a donor amplifier that had germanium outputs. They were TO3, not this mini style here. But I was able to source 2 original output transistors, so we'll install these and see what happens. It'll be these 2 right here. We're changing Q15 and 16. Okay, we'll just make a note of this first. The red is the collector. I believe the black is the base. I may have to verify that, but we got red, black, yellow, red, black, yellow. Okay, I've removed one of the original transistors here, and I have one of the new ones here in the tester. I just want to see how it reads, and we'll do the original next. And one of the originals. And the second new one. And the millivolt reading is higher. It was 25 on the first new one, 95, and higher on the original.
So far,
okay, update. Replacing those transistors, those outputs on the left channel, did not cure the issue.
$98 billion in forgivable loans. Now, these
Right
are loans
channel.
that if small businesses accept this money and use it to keep people on their payroll over the
Just
next 2 months.
not right.
College of Obstetrics and
Okay, so in closing on this edition, 2 new output transistors
fielding those phone calls from every
did not cure it. It's like an imbalance, an impedance mismatch. It's something strange. What I'm going to go for next, I'm going for the driver transistor right here. So stay tuned for that driver transistor. It takes me back to a troublesome unit 40 plus years ago that it ended up being a driver transistor. So I'm going to try that next. There aren't many left. There's only 4 transistors in this circuit.
The decision's already been made by Mr. Paul Hollister himself.
Interesting. How some people remind us of people.
Steve, do you think you're recovered enough?
Okay, I'm scoping the output of the right channel at the moment. It looks okay. The volume here.
Isn't anything ever easy?
I'm going to go over to the offending channel here. Alright, what's going on here? Oh, balance.
Sasquatch, take it easy.
Where's Jamie? Oh, you remember me? Attack, Sasquatch!
It clips. You can see it's not uniform here. Okay, raise the volume. Good channel. Balance. Right channel.
Sasquatch!
Left channel.
Attack, Sasquatch!
Okay, there's definitely a difference in the wave from the suspect channel, left channel,
covered by both Medicare and your state's Medicaid. Here's something important to
and the good channel.
Now you could get even more health benefits than you
The
already
good channel's centered. If you look at the middle of the scale, it's equally
to find out if you or someone you care about is
proportioned.
eligible. It's easy.
But on the
Call now to
suspect
talk with
channel,
us. We can explain it all and answer any questions.
it's negative,
Medicaid
and it's
gives you
clipping
benefits,
anything
and
above
Medicare
the
gives you
positive.
some too. But a dual complete plan can add even more benefits and features compared to original
The symmetry
Medicare.
is terrible
You'll have lots
on
of
this
doctors
channel.
and hospitals to choose from. Plus prescription drug coverage.
It's the problem.
And depending on where you live, a man barely alive.
So this is a new one on me.
Gentlemen, we can rebuild him.
That's the bad channel.
We have the technology. We have
Oh,
the
I hate this
capability to make
frickin'
the
probe.
world's first bionic man.
The good channel. Good channel is
Steve
symmetrical.
Austin will be that man.
Bad channel,
Better than he was before. Better, stronger,
it's negative.
faster.
It's negative. It's like a problem in the power supply. I'm just gonna have to bear with me. I'll get this, but I don't know where I want to go yet. Good channel. Bad channel. Good channel. Bad channel. Okay, I've taken upon myself to go ahead and change the driver this time. That would be Q14. And I tried to scavenge out of an organ. These are the frequency, the different modules for the different tones. The tone generator modules, and these are germanium, but these are NPN. So they're the wrong polarity. I need PNP. Hope I'm saying that right. Anyway, these are the wrong polarity. They're good transistors, wrong polarity, so I can't use these. If I just happen to have an ECG 102, and I have that, well, I just had that. I have that here. I've gone ahead and marked the collector so I don't screw up with a red dot there. So it's collector. I put a piece of spaghetti on the base, and it's right in here, so we're going to change that next. Nope, same disease, left channel,
Yesterday.
Typical.
right channel.
Oh, you've waited up for it. That's very nice of you.
Left channel.
Virus cases making today the highest daily increase in Boston. With cases on the rise, Mayor Walsh says it's critical we
Right
keep
channel.
up social distancing.
Okay, I'm just going to feed the signal into the input stages here. Bad channel.
Daily death toll this Sunday.
Good channel.
Avenues. Progress across the pond.
Bad channel.
Sin is out of the ICU.
Go up a little further.
Being treated for coronavirus.
It's clear.
Let's get our insight this evening from our disease expert at Tufts.
Clear.
Talking about
I've changed these two transistors, so actually all three, the output, the driver, and the pre-driver here.
Virus, how do those habits...
I may change this transistor again because it's just some version I picked up. I do have GE2s, but I didn't want to take my cryptic packaging apart. I may grab another Sylvania ECG here, 102.
I mean, first of all, just the obvious is that
Bad channel.
the other is that you might be sharing
Good channel.
the lung function. They can really create
Bad channel.
inflammation on their own, and so that
Good channel.
ability that they're going to get further inflammation damage from the coronavirus.
Maybe it's this bad boy. Or it's something around here. It's something around here.
Oh, so does that tell us the chances for getting a vaccine?
Yeah, we hope that it is helpful.
Okay, I'm taking out that WEP, Workman Electric Products transistor, and I grabbed another ECG 102A, and I got a bonus jackpot. I got like 6 of them in there, but they're not ECG 102s, they're 2N408s, which is comparable. So I'll stick one of these in there, so you never know. Okay, and here's our 2N408. It's a PNP, and it is referenced in a diagram online. Similar design. Okay, here we are with our new transistor installed, the 2N408, and we're ready for the smoke test. So power on, we'll hit the power
Even
here.
Goskowski says he's in for a 15th season.
Still
Patriots
crappy
all-time
sounding.
leading scorer and now free agent, says he has no plans to retire. Goskowski is recovering from hip surgery that limited him to just 4 games last season. Forbes magazine releasing their 23rd annual
Still
Major League Baseball evaluations today.
Crappy.
With the Yankees
Spraying the
topping the list
S's.
valued at $5 billion. The Dodgers coming in second
Distorted.
at $3.4 billion,
Crazy.
followed by the Red Sox.
Getting behind this storm, we're going to be in the winds later.
Bad channel.
Up temps in the 50s
Good channel.
next couple of days, and then we go into Saturday and things are looking pretty good for the weekend. We do have a first load up for Monday.
Back to where we started. This is really getting to be something.
All right, keep saying. That's all the news we have right now.
It's going to be a bad capacitor resistor, something here. These transistors are not the easiest to take out, to locate. Okay, I'm leaving this here for now. I've basically replaced everything. The last thing I've done is bypass the balance control because that felt a little funny. I understand the sweep of an AC signal symmetrically above and below the center line. All the power supply checks okay, but it won't go above.
So we're going to go flour, egg wash,
into the positive. It clips. Well, it's got something to do with the dual power supply. But why just one channel?
flip it on the other side.
All the voltages read fine.
So while that's going on, we're making a mango sausage.
I'll leave this here.
Mango already. We're cutting it in fairly big chunks. Red peppers and green onions. 1 spoon of sriracha, which is a type.
Okay, the last capacitor I just changed, C19, I left that out because it affects both channels. And I'll show you. This is what it looked like.
Ultimately up to the states to do that? Yeah, no, it's really...
And of course it doesn't
The
test.
states can do things if they want. I can override it if I want. But the national stay-at-home, just so you understand, 95% of the country is
Oh, it does say
stay-at-home. Like, as an
capacitor.
example,
It didn't
speaking
test a
with the
minute
great
ago.
Governor of Texas, Greg Abbott, the other day. He has a stay-at-home. A lot of people didn't even know it. But he had
So
a
even
stay-at-home
looking like
secret
that,
where Texas was, and he had a very strong,
it's still
actually a very
tested.
strong stay-at-home.
Well, that may explain
95 to 96%
why we still have the problem.
South Carolina, as you know, has it, which at one
So
point...
again, I'm just going to
week ago,
stop
they
here
didn't have
and
South
think this
Carolina.
out.
Another
I'm
great
guessing
governor,
power supplies,
No.
but the negative,
95% of the
negative 12 and
country is
positive
covered.
12
Now,
both test
the states
okay
that
under
aren't,
load.
And again, constitutionally, from a federalist...
Is 0.
If I saw a state with a problem, I would absolutely demand it. But they're doing great. And the states that aren't are
A
states
little better,
that
but it's still
have not
spraying
had a
the
big
S's
problem.
and
You have to reopen right now. The same way that it's up to the states to shut it down, it's up to them to reopen.
I
What
have
authority do you have?
great authority if I want to use it. I would rather have the states use it. I would rather, and this is so shocking for me. A lot of people say,
that's the left channel. Let's go over to the right channel real quick.
Sir, what metrics you will use to
Okay,
make that
once again,
decision?
right
The
channel.
metrics right here. That's my metrics. That's all I can do. I can listen to 35 people.
Left channel, still
At the
clipping
end,
at the top.
I've got to make a decision. And I didn't think of it until yesterday. I said, you know, this is a big
Nothing
decision.
above the center
But I want to
line.
be guided. I'm going to be guided by them. I'm going to be guided by our vice president. I'm going to make a decision based on a lot of different opinions. Some will maybe disagree, and some I'd love to
All
see
right,
where
that's
they
it
don't
for now.
disagree. Will there be risks?
I want everyone to understand there
Again,
are
one last
states that are
time.
testing.
Left channel.
There are states that are doing contact tracing. So, I mean, I think sometimes we get, we look at what New York is doing
Right
and
channel.
Detroit, we forget that there's a Utah and a New Mexico and a North and South Dakota and a whole series of states that have been doing testing and contact tracing and have been testing at rates higher
channel.
than that per capita rate that we all have discussed. So we're looking at that. What did they do? Where test comes
Left
in.
channel.
So when you put all these pieces together, you're trying to understand where would be the first signals. So we have surveillance out there right now with the CDC's influenza-like
channel.
illness. I hope you're all tracking that. It is showing these small changes. I think we can believe in that as a surveillance tool married with their syndromic piece.
I had an idea coming across concerning the... I'm looking at the output transformers now as being the culprit, and I'd like they meter different, and I would like to actually exchange them. But before I do that, I figured I would get a donor, and I have this junker here. Lo and behold, it's running. I powered it up, played with the switch. It's a what's left of a Juliet multiband, and I believe it has a similar setup. It has two SB outputs here and a transformer. I know it's a tiny transformer, but I was thinking of substituting that in the Panasonic. And it gives the J-deck equivalents, even though they're not 2N numbers. I shorted it out against the speaker. It got pretty hot. But these two here, 2SB 156, one there and one there, and that's the output transformer. 2SB 156 Hitachi. They're running pretty cool now. Here's a little pictorial from the web I found, and basically what's happening with this thing is how each transistor shares a portion of the wave, positive, negative, and there might be some inversion and phase, out of phase stuff, but it's not doing the top of the curve. It's flattening out. It's doing the bottom okay, but it's not going to the top. I'm checking resistors, capacitors. I'm still on it. Okay, excuse the noise. I don't have all shielded cables, but there's the good channel. I'm feeding 1000 hertz sine wave into it. And that's our right channel. Now I'm going to switch it over to the left. And have you take a look at that. Look at that. That's what we've got to try to overcome. And it's below DC. It's below the center line. Let me go back to the other channel. How much cleaner and clearer that sounds. Equally distributed above and below the center line. Equally distributed. The bias is just horrible.
Who's Roger?
Okay.
He's the choreographer with our dance troupe. He's the one who helped me buy Cookie. Was he sick, Jenny, like you've been?
What I'm thinking of doing here,
He got better so quickly, I'd forgotten about it.
I've put a regular signal in. I'm going back to the source. I know the output coupling transformers are suspect, this and that, but now I'm going back to where it all started in 1968, is this, and I've seen somebody with a similar issues where the rectifier wasn't putting out. Now this shares both the positive and negative. Both channels share the same supply, so I've been dismissing the power supply as a source, but power supply is always suspect. So I love the schematic. They say green, green, and then they don't say anything on the output, but I'm going to assume, of course, we're AC here. No, we're DC. So, yeah, 10.8. Maybe that should be, it says 12 in the manual, maybe that should be up around 15. I don't know. So, we'll see what this green pin here is nothing. Maybe that's just ground. Oh, there's our minus, okay. Minus 10.9. I've just never seen this problem before. And some of you folks may be... See, perfect. Minus 10.9. Oh, they're both minus 10.9. Alright, I'll look into that. This is on the schematic, and I'll reference it. But I'm going to replace this with this bridge out of this LED display thingy here. So we're going to take this out of here. And we're going to put it in there. Alright, I'm going to take this, use this as the main filter cap. This is from a Garmin satellite receiver or something. So I'm going to replace the 2200 in the power supply with this guy. And this is a 330. I don't believe I have a need for that. There's a 470 in there, but we'll scavenge that capacitor or save it for later. Okay, so here's what we basically got. Our transformer AC coming in, which is about 18 volts, and then going out positive and negative. And here's the old piece here. This is a Sanken, it says R204B. They have two negatives. Always something different here. But they have them jump together. A bridge with 5 leads on it. Here's the date code. Now we'll fire it up for the smoke test.
I do. Todd, one of the problems I have is that
Still
I can't
crappy.
But if I could, I sure would want to right now.
I could do that. I'm great at hugging.
Obnoxious know-it-all stage, and you think they'll never grow out of it. But eventually they do. I'm still hoping. See Martin on Frasier.
Still distorted. We're going to go ahead and change those filter caps next. Before I come up with a permanent solution, I just want to put a piece of cellophane tape across this so it decides to stay where it is, in case it decides to not stay where it is. I've also gone ahead and done the same with the stereo indicator, because if any of these touch, you're likely to blow the FM, and that's what works really well in this, is the FM. But that's an odd size, 7.5 volt at 75 milliamps. I did put a 6 volt bulb in there, it operates. So anyway, on to the capacitors there. I'm going to change this one and the 1000 right here for starters. And test again. The good news is there's no change. The bad news is there's no change. I did replace the main filter caps just for the heck of it, so that's done. The voltages are a little different, tiny bit. 11.1 on that base, 11.0, 11.1. 11.0. Over here on this base, we have 10.8. 10.8 on the emitter, or the base perhaps, and 11. So there's a slight difference. 11, 10.9, whereas these are 11.0. 11.0. Collector here voltage 11. Over here the same. There's something. We're going to do some more signal tracing, but there's something going on around here.
Alright, but turn the music down for...
Alright, so as much as I don't want to, I've been putting it off. I'm probably going to swap the transformers from the left channel to the right. That'll rule that transformer out. Okay, a little more documentation. I took this child's walkie-talkie and I wanted to make a signal tracer. So I just disconnected the radio. I can broadcast if I want to with the antenna here, but my Morse code. But basically I'm just tapping on the volume control and using it to probe the signal. I have a blocking capacitor there, and I just probe around here is our input. Right channel. Left channel, suspect. Sounds good. Go to the transistor, left channel. Oh, that must be the, here's the bass. Bass sounds okay on the other transistor. Go here to the, I believe the collector.
And a pair of young tree snakes are getting all wrapped.
I don't know, sounds kind of crappy starting.
Tangled environment. Nature's way to ensure the survival of.
Hard to tell. But if I go by this resistor here, here's an example.
Coming up, we catch a glimpse of a rare white.
Bad. That's a 1.2K. 1.2K. And this 1.2K.
And now for these commercial messages.
Sounds fine. Over here is where it. Aside of putting all the original transistors back in them,
Every month, we'll keep them safe all year round.
this is where it starts breaking up. This is so crammed in here, I'm telling you. I just hit good channel. The bad channel.
Thank you.
I've double checked my capacitors. They are installed correctly. So it's not going to be any good further on if it's distorted sounding here.
Not your allergies. Make every day blue.
And these are from the controls. Controls check okay.
Drowsy children and allergy relief. Outdoor and indoor allergens, because to a kid, a kill is irresistible. Children's medicine. Feel the clarity.
I don't know why there's 5 volts on these controls either. That's got me a little puzzled, but they both have 5 volts. So I'm going to look around here a little more. I may replace some of these resistors because they're impossible to test in circuit.
Bounce out wrinkles.
There's our distortion. Starting very early on. Okay, I'm getting ready to change that 1.2K. And again, I'm just trying to see differences between the left and the right channel. This is a long shot, but there's a lot of glue, wax. It was just wax. Maybe it became conductive, but that's a long shot because it is all around this resistor. So I'm going to clean that out of there.
Mission they deserve. WCVB Senior Shoutout.
During the coronavirus pandemic,
Okay.
the complex that was built to house roughly 15,000 athletes remains empty.
I'm on the base of that first transistor. I changed out the balance control just in case there were tin whiskers or something, but it's over here. It's at the volume control. I disconnected this tone cap here for the tap on the pot. The base of that transistor is very quiet. The collector is not is noisy, so it's got to be that replacement transistor. I'm going to put a GE2 in. I found some GE2s that are opened in the stash, and I'm going to stick one of these in here. But I'm going to socket it. I'm not going underneath that board again. That board is nuts under there. Well, I don't know what I've done. I've socketed the original transistor in. I've added some header sockets here, whatever you want to call them. I'm still running the ECG. I'm taking the collector of the driver transistor right now. I have this tone compensation cap off, but it doesn't seem to make a difference, and I'm in the positive now.
No, they're fine. What we're interested in is whether or not you have authorization to move that vehicle.
Well,
The resistors tested okay, so I don't know if they're noisy or what, but I've replaced the bias resistors. I've replaced the bias resistor. I keep saying transistors.
You're under arrest for Grand Theft Auto. Turn around.
So it's not that I've added the balance control here. The right channel, the left channel. So I think I'm done with this. I may socket and I'm going to put all the originals back in. I wanted to add the fact that there's a lot of corrosion here and pitting, so this wasn't a damp location, and that's why I was suspecting the controls had tin whiskers perhaps, even though they're not known for that.
Maybe it does, but it don't give you the right to push people around.
It seems to be working okay now. I've just been changing resistors, the bias resistors. I get a full sweep now. Bizarre. It wasn't the fact that I put the original transistor in. I don't believe.
Jim? What are you trying to say, Brett? Man, stay out. I'll have you know I'm Hubble's godfather. I'm seeing my lawyer about that in the morning.
But Fred, you don't understand.
Mrs. Rubble, may I have my baby?
Oh, of course, Fred.
Thank you. Now get out of my house. Come on, baby.
So we're good up to the collector.
Of respiratory illness, how to
and it feeds the primary of this transformer. I've been suspect of these transformers the whole time. There's only a few emitter resistors here and stuff. I may swap these out and put the suspect channel in the put the good channel in the suspect channel and go from there. Okay, I've gone ahead and removed both transformers, driver transformers, and I think my worst suspicions are true. I knew all along, but I dreaded taking these transformers out. Well, here they are. I have one with a green dot on it, so I know, and I've done some comparisons. This is the suspect one. I don't have, of course, and it's wired crazy. You look at the SAMs and it says, you know, 1, 2 on one side, primary, and then 1, 2, 3, 4 on the other, but it's 3 and 3, and the physical attributes don't match. You know, so what else is new? So what I've found so far is the good transformer has 192, the suspect 185, that's obviously the primary. I have the dot facing me, the factory dot. And I get 31.4, okay, this is our secondary here, between these two. And I get 32 ohms here on the other one. But it's this one here on the good transformer, I get 32 ohms from here to here, which is here to here, 32 across there. And on the left one, I don't get anything. I'll verify that with you if I can on camera here real quick. From here to here, I should just get my clip leads out. Oh, it's hard to do one-handed, I'm telling you. Well, there's our suspect. Nothing. Come on. Oh, 32. Okay, so this is the good one. No. Oh my goodness. Let me get back to you here. Okay, take 2. Good transformer, 32 ohms. 32 ohms, 192. Suspect left transformer, 185, 31.4. No 32. Although I don't have it written here. There you have it. This There's nothing over there. I'm going to go back over here. I'm going to go between the center and the right. 31.5. Perfect. I'm going to go from the left to the left. I get 0. I'm going to try again with the same transformer over here. I'm going to go from here, so it's not in the vise, the left, of course, to the left. 32 ohms. Why was I getting 32 a minute ago? Is there a bad connection on the, go from here to here? Nothing. Wiggle this lead around a little. Nothing. Wiggle him, because I swear I got something there. Oh. 30, there it is. It's this lead right here. Now I'm getting 32. Now it's open. I think we found our culprit here. This lead right here. My guess is, this being 16 ohm finals, nobody ran 16 ohm speakers and possibly overloaded it, who knows. This lead right here. I'm still going to swap the transformers. I'm going to put the good one in the suspect channel. And I'm just going to verify this one more time. That's open. I'm going to wiggle this lead. Pull it towards me. To the right, to the left, push it in. Yep. There it is. That's why we're flattening out and not getting... Something's wrong. Okay, I'm doing this one-handed, but if I press on this, I get continuity. Oh, and it's staying. If I pull away, I lose it. Something wrong with this lead. Okay, I hate doing this, or I should say, oh, it's going to fall off the bench. There's nothing worse than transformer work. Yeah, meter movement work. So I'm open right now and I'm attached. However, what I'm trying to show you is, yeah, I just move it and I get my connection. The wire's not broken. See, there it is, open again. It's as if I push on it, oh man, all I have to do is put a little pressure on it and I get it. The wire's not broken. I think it's just cold solder. It just needs to be reflowed. I'm holding it so I can't let go and do the loop, but you'll have to take my word here. Okay, once again, I'm going to take before I take the X-Acto blade and clean up that terminal, I just want to show you. It's connected and it's open. I want to try to give you a close-up here, but sure, it's dancing around now. It doesn't look terrible, but watch now. If I just take, I'll just take the blade here, the dull side, and I'm just going to hit the connection there, right there. Okay, right there. We're going to hit with the solder. We're going to scratch a little more coating off that transformer. Transformer's not melted, damaged, or anything. Just poor connection. Let's see. Okay, it's hard to see, but all I did was touch this wire. You can see it's not even connected there, see? I just went to scrape it, and it's off. Well, anyway, we're not going to play with this much more. We're going to solder it. We're going to close the suture it up, and put some stitches, give it some aspirin, and hopefully not on a ventilator. Okay, can't get much closer than 32 ohms. There we are. Get some focus here. Here's our repair. I may hit it with some flux cleaner. I may leave it. I'll clean it off. Okay, I added some flux when I did solder it, and I did take a little cleaner and I just cleaned it. But you've heard me say this before, the name of this game is get in and get out. So we're getting out. Okay, very quickly, one last check. We should have 31. This is the, I don't know, we'll call it the bottom half of the wave. That's one winding. And then we'll go to our suspect terminal over here. The other lead. And we'll check for 32 ohms there. Beautiful. And we'll check our primary real quick, which is 185. We'll compare it with the SAMs in a minute. Fine. And there's our SAM showing the 33 and the 33, but look at how it's drawn. It's no way like that physically on the transformer. That's the problems you run into. And of course the silly factory one doesn't even designate what it is. Maybe you're supposed to just know. I've taken so many pictures, that's good though as a reference in case you wanted to put the transformer in the wrong way. Okay, that's how it goes. The writing facing the front. That was it.
All right, Russell, you've got yourself a job. I appreciate
that. Was it. Left channel. Look at our balance here now. Right channel.
You know him pretty well, Lucas? I used to mark him.
Suspect channel.
Mark and me get settled when we first came here. Son, I was hesitating because of you.
Sounds beautiful.
But Pa, he deserves a chance just getting out of prison like that.
Beautiful.
And besides, you've been threatening to clear up that field for 2 years now.
Transformer.
I never know you, Mark, whether you're being charitable or practical. Never can understand Russell Robbie, that coach. He was a respectable rancher.
The tuning's off a tad. That's 107. Don't worry about that later. Stereo does work. I see one of our wires has snuck out of the insulation here. That'll be catastrophic. Two things: we haven't hit the dial string with the soldering iron, which is a fatal mistake, and grounding out the FM stereo indicator would be another catastrophic failure. The FM stereo does work. AFC also works. It mutes when you're on FM stereo.
I think that's so too. Huge hit to the whole show. My baby don't tolerate. My baby don't tolerate.
I don't think this station is in stereo.
How do they deal with
Alright, we'll do some more testing when we get this thing back, but I'm good.
Fund, visit country1025.com/heroes. There's no donation too small, as every bit counts. We're all in this together. Healthcare Heroes is made impossible.
I suppose if I want to hear stereo, I'd have to have both speakers on.
4:45 as Jackson Blue goes commercial free for 90 minutes. You don't talk about dinner party.
Light Rock 105 wants to thank you.
Alright, that's good for now.
1-800-916-2959 or go online at NutriChopper.com. That's 1-800-9.
Go back to the television.
NutriChopper.com. Order now.
Beautiful. That thing was running me in circles. I'm going to put the original transistors back in and button this thing up, hook the balance control back up, and get back to it. It wasn't capacitors, it wasn't transistors, it wasn't capacitors. It was a poor connection on this transformer. I did put it in the right channel, but I'm running the suspect channel on the other transformer, but poor solder on the secondary of the output driver, not output transformer, this doesn't use them, driver transformer. Okay, I think that's going to do it. We'll do one more with it all back together. Thanks for watching.
Where's he?
Okay, I've attached all the front panel controls. We'll just put some kind of stereo indicator light in it and we'll be good. Balance. Right. Left. I'm going to switch those speakers. I thought I had the left over here. I've taken these two speakers and I've series them to give me 16 ohms, I should say. So that one over there is still 8. Actually sounds better with the 16 ohm, actually.
Okay.
It's going to be absolutely gorgeous today.
It's
sunny at a high around 60, maybe a few afternoon clouds.
We have
Tomorrow, look for more clouds.
the worst morning DJs here. Ha ha ha, yuck yuck yuck, ha ha ha. Everything is, it's not that funny. Anyway, what we're going to do here is I'm going to address this stereo indicator. I've done this in the past. What I've gone ahead and do, I picked up these, I think last year, Christmas LED replacements, and I got to tell you, I already lost one here because I was using the decade box, and when you put it on 0, it puts the full voltage to it, so I wiped that one pretty well out. So I have one cool white left, so I'll show you what I'm going to do. Okay, so I have the lab supply at 7.5 volts. And I have the box, right now it's on 1,000 ohms. I know about 560 or so is good for 12, using Ohm's law and whatnot, but I'm just going to wing it here. So you can see 1,000 ohms, if I go down in resistance, it will get brighter, but I don't. I'm going to shoot for about 1,000 ohms. I can go up here to 10K. And the same thing, it'll go dimmer as I go up to 10K. So 10K is a little, looks brighter on camera, but that's really not enough. So that's 1,000 ohms right there. That behind, I'll try to reach behind the dial face here, but
But she's not home because she's a healthcare giver.
I don't know. I don't know. Maybe. Maybe. Yeah, maybe 1,000 ohms will do it. Again, if you go to 0 on this, you put the full potential across it, and that'll pop right out. So here we are at 200 ohms. 100 ohm, 200. I don't know. Again. Kind of like it like right there. I kind of like about 200 ohms. Okay, there we are. 220 ohm is my choice. I just have it tacked in here for the moment. It's funny, I don't know why it's still lighting when I'm not in. Oh no. Not even in stereo, and it still lights. Maybe that must just be the way it is. That station is not in stereo. Stereo, I'll leave it in stereo.
ICN is doing Worcester community.
That is stereo.
Can be challenging for many people. WICN.
Put that behind the dial and see how it looks.
HPE doc. That's 3. These feet. 1041. For more, go to radio.
Alright, we'll leave that. Perfect. Okay, there we are with our new lamp installed. No danger of shorting, and we did not hit the dial string with the heat gun either. And there we are with our new stereo indicator installed. Next up is to put the original transistors, the driver and the pre-driver, back in. The capacitor I'll leave. And that's about it. This channel's been recapped. This channel's original. Not capacitors. Okay, I've gone and added another in series 8 ohm speaker to make the other channel 16. I should watch my connection there.
Love.
The FM is really good on this, meaning it gets the stations between the stations. This station is probably close to 50 miles away. And it gets it in between
it is bizarre.
the two stronger ones. It's sandwiched right there, and this AFC really does lock it right in.
Thanks for listening.
I was listening to this Casey Kasem rebroadcast classic American Top 40. I was saying these songs don't sound right. They don't sound the same. You know, I may sound dated when I say that, but I remembered that when that came out, and they don't sound right. And they just said digitally remastered by blah blah blah. Well, that's the reason right there. They just don't sound. They're the same song, but they just don't sound right to me anyway. Okay, last but not least, I'm going to put in the original. I'm going to socket with these headers the original two remaining transistors. The outputs I'm just going to keep the new ones in there. I'll keep these in my stash. These are still good. These are the original outputs, which are still fine. Oh, this music is... I have to Shazam it just because it's so bad. I have to know who it is, so I avoid it. Okay, driver transistor replaced with the original. I just want to show you how difficult it is getting in this area with all these components tacked on the bottom, but there we are. Our third socket. I think it's there. This capacitor is tacked to it, and the collector is over here. Next, I'll take some flux cleaner and just clean up around this area here, make it look nice. Okay, this is how it shall remain. Sorry, I hit that little capacitor, the heat from the desolderer, got that a little bit, but other than that, we're all cleaned up. Trimmed our leads. Okay, we're good on this side. On the top side, we don't want any transistor fatalities, so according to our notes, the emitter, base, collector. Emitter towards me, base over here, collector. And these guys have a way of shielding the base. The emitter is open and the collector has the red marking on it. Okay, so there we are with all the original, the first audio, the second preamp, the driver, and the outputs are replacements, but I'm going to leave them because I don't want to go in there again. They're all heat sinked. Let me tighten them up a little. So there we have it.
Bring back all the memories. Toast to the ones that
31025.
And leave it here. So this is going back in the cabinet. We have plenty of ECG 102s, the substitute, and plenty of GE2s for our next project. Okay, here we are all buttoned up on the final assembly. I'll let you know that although one tried to get away from me, I'm not missing one screw or one lock washer. And the precision of this cabinet, it just fits exactly together. And the rest of the whole unit as a whole, the manufacturing of this is so precision. It's nothing like you'll see again in this sort of arena. This is just fantastic the way it's manufactured. Precision, quality.
I've been tickled in the morning, I've been tickled in the noon. So there's something always. Once I put pepper in.
Okay, in closing, after many weeks, we'll say, I can finally use this for what its intended purpose was to test this BM1257 that we just restored. So here we go. course, I can't let them play. Can't let them play.
You can't stop this rockin' and a rollin'. It's been here. In the stereo part of the city.
Left channel.
A woman was made to be loved. Yes, a woman needs